there's a way for me to turn the page without stopping.
Where's my calculator? I wish there was some way to have this more desk space and have this turn its page on its own.
Ugh. I wish there was some way I could turn this page and still be able to hold on to my dog.
It's like how people approach me about not wanting to use their hands to turn a page on a book.
Like a musician?
Or someone who's cooking?
Yeah, all that. But what is this thing supposed to do?
Well, we're gonna need it to be able to turn a page without ripping the paper.
And it's gonna have to work for different size books.
I mean, and it's got to be able to turn a single page because you don't want to turn two pages at once.
Yeah. So, I don't know, what kind of design should we think about?
Maybe using a foot pedal so that you don't have to use your hands.
We could also do two motors, one that spins it and one that lifts the actuator up.
Yeah, is there a way to make that easier with one motor?
Maybe we could use like one motor and a ramp.
A ramp works, then we don't have two motors. So how do we want to attach it to the stand?
We could use clamps and a battery so we can make it portable.
That works. What materials do we want to use?
We could always 3D print it because that's nice and lightweight and we can kind of make whatever we want with it.
Yeah, and then we should probably make sure all the rest of the parts can be ordered on Amazon or at a hardware store.
Alright, sounds good. Let's get started.
First component of our design is a base plate that will hold the motor in its housing. The next part of the design is the motor housing. This has a ramp so that as the link rotates, it doesn't fall below the stand and it is lifted up to pick up the next page. This next component is connected to the motor but rotates freely so that it can rotate the page turning arm. The first link is free to move up and down so that the page turning arm can move up and down the ramp. The second link is fixed at where it connects to the first so that it can be adjusted for any size book.
We decided to 3D print the parts because this makes the page turner more lightweight. Also, 3D printing allows for more complicated pieces to be created more precisely. A couple of the parts had to be reprinted due to changing designs as well as printer failure. The rest of the parts can be found at your local hardware store or ordered online. This allows the page turner to be made more quickly and for less money. You'll need some wire, a battery, a motor, electrical tape, and a switch. To put the switch together, first put the wire inside the casing, making sure that it fits securely. Next, place the spring on top of the button, place the push button in the lid, and secure it using the screws provided. Next, attach the battery and connect your system.
In order for the link to be able to grab the page, we cut a bouncy ball in half and glued it to either end so when the link passed over the page, it would adhere to it and drag it along. In order to attach the link with the bouncy ball on the end to the link that didn't have a bouncy ball on the end, we threaded a wing nut through and put a screw through so we could rotate it and adjust the link to whatever length we wanted. With our previous design iterations, we had to glue the motor shaft into the connector piece, but this motor shaft was big enough that we could just attach the connector piece by hand. After that, we slid the links into the connector piece and slid a screw through the holes we cut and tightened it on with a wing nut, but loose enough that it could still go up and down the ramp as it rotated. After that, we fed the wires through the base plate and attached the motor mount to the base plate. So this was our original motor and connecting piece. The problem with this motor was it just wasn't big enough, the shaft wasn't long enough, and it didn't have enough torque behind it, and our connecting piece wasn't quite big enough, because when this motor shaft was supposed to fit down through there was just too much friction between this piece and the top piece, and the motor power just couldn't overcome it. So we printed a bigger piece that wouldn't have quite as much friction in the hole through the ramp. But by the time we printed this, we had already ordered our other motor, which would be much stronger, which is why we had to print this taller piece, which has a much bigger, much more powerful motor. And because we had a much bigger motor and much bigger ramp housing, we had to print another base, which is why we have this much smaller base, which has a much bigger diameter than the smaller original one.
This Excel sheet shows every possible position that the page turner can be in, including every possible combination of angles, both between link 1 and horizontal, and link 1 and link 2. Horizontal is considered to be in line with the music stand. The connecting line is an imaginary line connecting the beginning of link 1 to the end of link 2. The length of this line is calculated using law of cosines. The angle between link 1 and link 2 varies from 0 to 180 degrees, and the value of the connecting line is calculated for every 5 degrees. The angle between link 1 and horizontal ranges from 0 to 90 degrees, and again, values are determined for every 5 degrees. The angle between link 1 and the connecting line is determined using law of sines. Once the length of the connecting line and the angle between link 1 and the connecting line are determined, the resulting vertical and horizontal distances can be determined using trig functions. Red X's are displayed in cells with an impossible value, where the arm goes below horizontal or the crank becomes inverted. White X's are the corresponding values for an impossible value. The sheet lists the total combinations and the number of possible combinations, as well as the maximum length and height and their corresponding values.
Looking back on this project, we came up with a few design improvements and alternate designs. First, we considered programming the motor to make one rotation per click of the switch so that the motor does not need to be clicked once to start and again to stop. Next, we thought of putting the motor on a timer so that for a musician, they wouldn't have to use the switch at all. Next, we should find a switch that doesn't audibly click so that it wouldn't disturb a musical performance. Finally, with extended money and time, the switch could be paired with the motor through Bluetooth so that no wires would be.